In this tutorial, we're going to be looking at the measures of spread of a discrete probability distribution. And there are three things we're going to be talking about. Firstly, the variance of x and what it is and how it's calculated. Secondly, the standard deviation of x and how it relates to the variance. And lastly, the 95% confidence interval and how it's calculated. First of all, let's look at the variance and standard deviation of a discrete probability distribution. What is the variance? The variance of a probability distribution gives us an indication of the spread of the distribution. If the variance is a large value, this tells us that the values in the distribution are spread a long distance from the mean. In other words, the data values are spread out. If the variance is small, this means that the values in the distribution are close to the mean. So in other words, the data values are close together. The variance is the measure of the spread or dispersion of the data. When we write down the variance, we write it as var x, VAR in capital letters, x in a bracket. It's also sometimes written down as sigma squared. The formula for calculating the variance is as follows. Var x, or the variance of x, is equal to the expected value of x squared minus the expected value of x, the whole thing squared. To illustrate, let's look at this example. In this example, we are meant to find both the expected value and the variance of x in the following probability distribution. So how do we go about this? We know we need to use this formula. Var x is equal to the expected value of x squared minus the expected value of x, the whole thing squared. So we need to find both of these values first. We need to find the expected value of x squared and the expected value of x. When we have both of these values, we need to sub both of these values into the formula. So this is how we go about it. Firstly, add an extra row to your table which shows x squared. So if these are my values of x here, 1, 2, 3 and 0, when I square each value I get 0, 1, 4 and 9. The expected value of x squared is found using exactly the same method as finding the expected value of x. I take each value of x squared and multiply it by its associated probability. So 0 times 0.25 plus 1 times 0.35 plus 4 times 0.2 plus 9 times 0.2. Add them together and I will get 2.95. This is the expected value of x squared. Now let's find the expected value of x, finding the method talked about earlier. I take each value of x and multiply it by its associated probability and add them together. So this calculation looks like this. 0 times 0.25 plus 1 times 0.35 plus 2 times 0.2 plus 3 times 0.2. Add them all together and I get 1.35. Now I'm going to substitute these two values, the expected value of x squared and the expected value of x, into my formula. So here it is. The variance of x is equal to the expected value of x squared minus the expected value of x, the whole thing squared. So I have 2.95 minus 1.35 squared. 1.35 squared is 1.8225. Take this away from 2.95 and I get 1.1275. So the variance of x is 1.1275. Now, the standard deviation. The standard deviation is calculated from the variance. It's another measure of spread which is calculated. This is written down as SD of x. SD standing for standard deviation, so we have the standard deviation of x. Sometimes we just use the sigma symbol to stand for the standard deviation. The standard deviation is simply the positive square root of the variance. So it's written like this: the standard deviation of x is equal to the square root of the variance of x. In the previous example, the standard deviation of x would be equal to the square root of 1.1275. And therefore, the standard deviation of the distribution in the previous example is 1.06184. Now, let's look at the 95% confidence interval. This is calculated from the standard deviation. So once we have the standard deviation, we can work out the limits of this interval. For many probability distributions, approximately 95% of the spread or distribution lies within 2 standard deviations from the mean. Therefore, the distance of 2 standard deviations from the mean, either below or above it, is known as the 95% confidence interval. We're going to look at this example and find the 95% confidence interval for the following probability distribution. Firstly, we have to find the mean of the distribution to calculate the standard deviation. We know that the mean is equal to the sum of the x values multiplied by their probabilities. When I perform this calculation, I get 2.95. Secondly, I'm going to calculate the expected value of x squared. When I square all my values of x and multiply them by their probabilities, this is what my calculation looks like. I add them together and I get 10.15. Substitute these values into our formula to find the variance of x. The variance of x is equal to the expected value of x squared minus the expected value of x, the whole thing squared. This means that this is equal to 10.15 minus 2.95 squared. 2.95 squared is 8.7025. I subtract and I get 1.4475. So therefore, our variance of x is equal to 1.4475. Now I'm going to use this value, this variance of x, to find the standard deviation of x. We know that the standard deviation of x is equal to the square root of the variance, so I'm going to find the square root of 1.4475, and I get 1.203. Now I'm going to use these values of the standard deviation to find the 95% confidence interval. Because the 95% confidence interval is 2 standard deviations away from the mean, I'm going to double the standard deviation of x and subtract this answer from the mean. When I do this, the mean is 2.95 and I take away 2 times the standard deviation. I get 0.544. I'm going to do the same thing, double the standard deviation and add it to the mean. So this time I've got 2.95, the mean, plus 2 times the standard deviation, which gives me 5.356. Now I'm going to use these values to work out the upper and lower limits for the 95% confidence interval. The upper limit of my 95% confidence interval is 2 standard deviations above the mean, so it's 5.356. The lower limit is 2 standard deviations below the mean, so that will be 0.544. Lastly, I have to interpret my solution for the discrete probability distribution. Now remember, this distribution involves discrete data, so I can only have whole number distinct values. My upper and lower limits at the moment are not whole number distinct values. They are decimal approximations. So what I do is I put those values into my table and see where they sit. My lower limit, 0.544, is below the minimum value of x in the distribution. So if my minimum value of x is 1, 0.544 is below this value, so it would be over here. My upper limit, 5.356, is above my upper limit in the distribution. My largest value in the distribution is 5, and 5.356 would be higher, or over here to the right of this value. So therefore, all my discrete values of x in the distribution 1, 2, 3, 4 and 5 are included in the 95% confidence interval. Therefore, for this distribution, the 95% confidence interval is 1 to 5. Thank you for listening.